So the way polar coordinates work is you are given an angle and a radius to find your point. So for example, in this first one, we're given an r value of 3, so we know our point is going to be 3 units from the center, and then we're given an angle of 5 pi over 3. So these are actually easier to work, or really better to work backwards, where you start with the angle, then graph your radius. So angle of 5 pi over 3, we know that's going to be in the 4th quadrant, so along this line approximately. And then a radius of 3 means on that line we go out 1, 2, 3, and there's that point for part A. So now either the angle can be negative or the r value can be negative. So first, looking at 2, negative pi over 4, again, it's best to start with the angle. So if we go negative pi over 4, that's 4th quadrant, approximately halfway. And then we already used the negative on the pi over 4, so now it's the same as before. Just go out 1, 2 on the circles. So next one's 3, 0. This looks like a normal coordinate. So in this case, again, theta is the second part, so it's an angle of 0. I think that's on that x-axis line, and then you're just going out 1, 2, 3. So there's that third point. And the last one, and this is where it gets the most confusing, is when you have a negative r value. So still, go to the angle first, so pi over 4. That's going to be halfway from the first quadrant, but now you're going to go the opposite direction for the r value. So this is why it makes most sense to go to the angle first. Pi over 4 is up in the first quadrant, but we're going to go the backwards way. Go backwards, negative 2. So that's where point D would be. So now with that negative aspect and working backwards, you should be able to tell right away there's probably other ways that you can get to that point. Because technically, that's on the line. So here's 4 pi over 4. So really, that's on the line 5 pi over 4. So another coordinate we could have given that would be, we could say positive 2, but then 5 pi over 4. And that would be the same coordinate. So we're going to look at that a little bit more in the next slide. So let's consider the point 2 pi over 4. Our angle is pi over 4. That's about halfway. And we're going out 2. So other points we could use for that. First, we could keep our positive. So we could still say a positive 2. But instead of thinking pi over 4, which is the positive angle, we could think of this as a negative angle. And to go backwards to get there, that's the same as saying negative 7 pi over 4. Another option, and this is where we take into play the negative r value, we could go to the opposite side. So let's see. That is 1 pi over 4 past 5 pi over 4. So we could go to 5 pi over 4, but then work backwards. So negative 2 5 pi over 4 would be the same point. Another option, we could still work with this backwards line, but go there going the backwards direction. So we could say negative 3 pi over 4, because that takes us to that backwards line, and then put a negative 2. So as you can see, there are multiple ways that you can come up with these points. There are not unique coordinates when it comes to polar coordinates. So throughout the rest of these notes, practice plotting points and practice coming up with some other coordinates that takes you to the same point.